Okay, welcome to our tutorial for setting up the EDS on our Hitachi SU3500 SEM with Oxford EDS capabilities. So the first step is to get your sample into the SEM and have everything set up just like you were ready for a good imaging session. Now, once you're here, there's 3 important steps you'll need before you can run EDS. And they are a working distance of at least 10 millimeters or more. The EDS detector needs to be inserted, and you also need enough electron energy to receive a few thousand counts per second. So typically at least 15 kilovolts for looking at all the high energy elements, and a 50 to 60 spot size is usually needed to get enough of a signal. All right, so we're going to start from the working distance. So on the SEM, we're going to hit the stage here, and you can either type in 10 here and hit enter, or you can just hit this convenient EXZ10 button. So that's going to physically move the sample down further away from the electron source to a goal of 10 millimeter working distance. So you can see the electron focal distance has tried to reach the correct number, sort of tried to follow the sample, but it hasn't hit it exactly. We're out of focus. So I'm just going to adjust the focus knob to get us back into focus. There we go. And I'm not going to spend a lot of time trying to get this image just right. But if you would like to, just follow the typical SEM steps. That'll do. Okay, that's our working distance of 10 millimeters. So now we're going to head over to the EDS computer. And we're going to open up Aztec. If things aren't working, nothing's communicating very well, run this tidy up program, and that usually helps. But for now, everything seems to be working okay, so I'm going to run Aztec. So create a project for yourself. It's basically a folder in which all of the EDS data is going to live. So on the D drive, pick your root folder. I'm just going to call this project. Demonstration. Okay. So the first thing I want to do before we can take any measurements is to insert the detector. So down the bottom right here, there is the control of the EDS detector. Go to insertion, click in. And if you look over to the left-hand side of the SEM, you'll notice that the Oxford Instruments detector is moving in towards the machine. Okay, that's complete. So an important metric for our EDS is this counts per second metric here. We want at least 3,000 or 4,000. So right now our signal to noise ratio will be too low at this 1,000 value here. Currently I'm using 15 kilovolts and a spot intensity of 30. So I'm going to raise the spot intensity over on the SEM machine up to 50. Okay, that should be plenty of signal. Over on the SEM machine as well, the image is out of focus, so I'm just focusing again because I changed that spot intensity. Okay, so now we've got our 3 essential elements for doing EDS, our working distance at 10 millimeters, detector inserted, and enough counts per second to get a good signal. So we're ready to start. Okay, so you can see by default, we've got the software creates specimen 1, site 1. So I'm going to rename this specimen 1 to something helpful. This is the SEM standard. Okay, so if your sample is coated, make sure to note that here. It'll just exclude it from the analysis. So if your sample is coated with platinum, for example, and how many nanometers, you can include that here. Press to check the predefined elements. I think it typically says what the previous person did, so you might want to just clear all, or unless you know what you're wanting to exclude, just hit clear all. And it's always good to tick perform auto ID during acquisition, because then while it's running, it will start to automatically ID all the elements. Okay. So the first thing we need to do is bring image into the software. So always check the settings here. We're going to take, depending on which image you like or what you've got it set up for. Right now I've got it set up for a secondary electron image. And this is going to be a total frame time of 40 seconds. That should be a nice image, 2048 pixels and 12 microseconds. So now I should be able to hit start. In order for this to work, you want to make sure that the SEM computer is running, so it's actually in the middle of scanning, and that your image looks good. Whatever your image looks like on the SEM computer should be what it looks like over here. Now we have our image that we're going to use to pick points in which to capture EDS from. So right now we're in point and ID mode, so we'll start there. Today I'm going to show you how to use the map and the line scan features. So we'll go over to acquire spectra. And I'm just going to use point mode. So in this mode here, everywhere you click will be another point that takes a spectrum. We'll just check the settings. Should be fine. Okay. Now wherever I click, it's going to take a spectrum. So I'm going to measure one of these particles. It's tin particles. And then I also want to see what's the surrounding substrate. And I'll check another particle too. Keep in mind that your spot size in EDS is on the scale of a micron. Not only is it a micron wide, it's also a micron deep. So make sure to think about what is a micron beneath your surface, and that's what you're going to pick up the image from as well, the information from as well. We do have a background signal of aluminium coming from this EDS. I think we have some contamination somewhere in the system. So you can see the scan is proceeding over here. Once the signal to noise ratio is kind of settled in, it's not changing anymore, you can hit stop over here and it'll head to the next spectrum. So you can see pretty clearly we have a tin particle here and a carbon, likely a adhesive carbon substrate over here. Picking up some signal from tin, there might be some little pieces of it around here. So the spot size is about a micron, so anywhere around here it could be a little piece of tin. Right, that looks good, so I'm going to click stop. And it's quite easily recognized this another tin particle. We can choose to display them in percentages here. And you can zoom in on the spectrum, move it around, click and drag, or zoom in with the scroll wheel. Okay. I Now we've got our 3 spectra. Let's take a look. So if you're curious about any other peaks that it hasn't identified, you can use this question mark tool here. Double click on the spectrum, and possibly carbon, more likely aluminium to go along with this aluminium peak here. It might be a combination of the two, but the percentage is likely so low that you wouldn't want to include it in your analysis anyway. But if you did want to force it, you would click on carbon, click include. Okay, so that's individual spectra. So this is going to be a lot more information rich than the map we're about to take. I'll show you how to take a map also. Go to map mode. We're going to stick with the same spot here. So we'll go straight over to scan image. And we've still got this image already loaded. You can see on the right-hand side here, this information tree. So we've got our standard sample, the first site we've chosen to look at. And we've got electron image 1, 3 spectra we've taken. Now we're going to acquire a map. So I'll just check the settings. At 256, it'll still be run quite fast. And you can see this image here is on the scale of around, say, 5 microns here, 10, about 12 microns, and we have a pixel size of around 1 micron. So if we do 256 by 256, that's more than enough to capture all the information we're capable of capturing with a pixel size of 1 micron. I'm going to set it to until stopped, so it's going to keep refreshing. And once that information stops sort of changing, we can hit stop. Let's click start. So it should fill it in more and more. And once it settles in, it doesn't look like it's changing anymore or improving anymore, you can hit stop. So right now we can see really clearly with this map that we have tin particles on a bed of carbon. And it doesn't look like it's improving anymore, so I'm going to hit stop. So when you're looking at maps, it's really important to consider what this color scale represents. I'm going to include an element that is likely a very small background about. So I'm going to force it to include aluminium. And I'm going to go back to data. So this looks like there is a little bit of aluminium everywhere. That's because this option here, this auto brightness, is chosen. If you choose this normalized brightness, now the percentage is actually represented universally across all these. And you can see how there's practically no aluminium here. The brightness is so low. It's typically, let's check that map sum spectra. Here it is here. You can see there should be like 0.2% of aluminium. Just that background noise that we get. So we go back here. Our data. So this setting here, where all of the brightnesses are normalized to one another, more accurately represents how much there's maybe this background information of aluminium here. Whereas if you represent it like this, it looks like there's the same amount of aluminium as there is carbon everywhere. So just be really careful how you're representing your data. Okay, so that's how to acquire a map. Next, have the Linescan function. So I'm just going to do the same area. So we'll go to scan image, and we've already got our image. So I'll go straight to acquire line data. Now I don't want to look at this map anymore while I draw my line. So I'm going to go over to the information tree here on the right-hand side, choose electron image 1. And then I'm going to, let's see, this is multiple line scans. I'm just going to do a single line scan. And I'm going to do it across this large particle. Check the settings. duration. Okay, so we're good. Let's start. So these buttons at the top here will give you different displays of the data. So make sure when you're using this tool, you keep an eye on what setting you have here. It's easy to miss. You might be looking at this thinking, where's all my data? So make sure you choose the appropriate setting you'd like to look at. So this is not normalized to concentration, but it counts per second. But it really clearly shows where the carbon is, where the tin is. And I actually don't want to include this aluminium. So what I'm going to do is construct line scans. I'm going to select aluminium and I'm going to exclude it because I know it's just a background signal. It's not really there. I'll let it finish. The signal to noise ratio is still improving with additional scans averaging together. All right, I'll hit stop. That's good enough for this demo. Now we have our line scan data. Okay. So now what we'll do, just as a demonstration, if I did want to move to a different sample, I would click here, new specimen, and I could rename it to something useful. Oops. Standard 2, for example. But what I'm actually going to do is go back to standard 1, and I'm going to add a new site. So I'm going to move somewhere else on this sample and take some more spectra. So to add a new site, you go to the scan image step, click new site, and then over on the SEM computer, I'm moving to a different location. And now my settings should be the same as they were before, a secondary electron image. I'm just going to hit start. And it always gives you all sorts of warnings, but that's fine. So now we're adding another electron image to site 2. Yeah, so we have our image. I'm just going to add a couple of points. Let's say one here and one here. Yep, the spectrum was good. Stop. And spectrum looks good. Stop. Okay, so now to export your data. The best way to export your data is in a report that creates a Word file for you. But it does it one site at a time. So I'm first off going to export site 1. We'll click on this report results, just this little triangle here, and we'll choose site report. That'll include all the information in the site. So I'm going to call this, let's see, this is demonstration site 1. It doesn't include the sample name, so I'm going to include that now. So I'll put site 1, date, time. It'll go through and take screenshots of everything. Finish. Okay, so now we have our report with the electron image, the location of all the spectra that we took, including the line data. Got spectrum 1, 2, 3. We should have the map data. The map sum spectrum is the average of the entire map. And then we've got our line scan data as well. So you can export all these things individually to text files. So you right-click, export. I think EMSA is a text file. So you can do all these things one by one if you'd like to plot them differently. But typically, those Word reports are enough. All right, so now that I need to also export Site 2. So I'm going to Site 2, click on Site Report. I'll include the sample name. And now we have all the information from Site 2, the image, and the 2 spectrum. Okay, so I'm done taking EDS spectra. So what we'll do is withdraw the detector. Wait for that to finish. And this project is auto-saved. So if you get back to your desk and you realize that you haven't exported everything correctly, all the data is still saved here. I'm going to close the EDS software, and that project would have been auto-saved. So now you would just want to shut down the SEM like normal. Thanks for watching.